Hello, let me introduce myself. I'm Rupert Shepherd. I'm the Collection Information Manager at the National Gallery in London, and I'm talking with my colleague Jeremy Ottevanger from Sesamoid Consulting, and we're going to be talking about the National Gallery's online catalogues project. Now, and our recent work to put print catalogues online. The talk today falls into three parts. I'll introduce the problem and the solution that we adopted, and Jeremy, who worked on the technical aspects, and I will also talk about the solution in more detail as we discuss a series of projects which are leading up to the web publication of catalogue entries for the gallery's paintings. Now, for those of you who don't know us, I'd like to begin by introducing the National Gallery on Trafalgar Square in London. We were founded in 1824 and are a national museum. We hold the UK's national collection of paintings in the Western European tradition, dating from roughly 1250 to a little after 1900. Now, because we were founded from scratch, we didn't inherit an existing royal collection or anything like that. We have very few objects in museum terms, only 2,393 paintings as of today in our main collection. But now I need to take you back to the Second World War when, as is still happening today, culture and museums were threatened by bombs. And so the gallery's paintings were evacuated from London, ending up in a slate quarry in Maarjamäe in North Wales. Here, free from distractions, the gallery's staff, notably Martin Davis, the man on the far right, could give their undivided attention to the paintings. The result was a series of catalogues arranged by School of Painting, the first of which was published immediately after the war in 1945. These set a new standard in the detail and thoroughness of their assessments and descriptions. And work on the school's catalogues, as they were known, continued until 1971, and they eventually extended across the gallery's entire collection. In the early 1990s, we decided that the school's catalogues were in need of a complete overhaul and began work on a new series. The first of these was published in 1998. They became known as the Painting series from the title of the individual volumes. With their large formats, lavish full-color illustrations, extensive discussions, and detailed scientific and technical information, the kinds of things that all has been talking about just before me, the Painting series again marked a significant step forwards in the publication of museum catalogue information. So far, 11 of these catalogues have been published, with another one in the press, and between them they cover about 850 paintings. But these catalogues are also the problem. Much of the gallery's knowledge is effectively contained in a highly traditional medium, printed books. If we think of the use of movable type, these go back in Asia to the 14th and in Europe to the 15th century as a medium. And our printed catalogues are large, expensive, and in many cases they're now out of print. In digital form, they mostly exist as Quark Express, or in a few more recent cases as Adobe InDesign files, which are difficult to reuse. Now, we could use those files to generate PDFs of individual entries, but they would be far from ideal because they'd be laid out for print, not for on-screen viewing. For example, we'd have to move readers around between many different sections, as much of what they need is contained in the front and back matter, not the individual catalogue entry. Things like information about how the catalogue is organized, abbreviations and glossary terms used in the entry, guidance on historic dates and measurements and how they've been treated, full references for any publications and exhibitions cited in the entry, and also any appendices referred to in the entry. Whereas what we really want is to preserve readers with everything they'd need on a single page, without having to link out to read the next section or to consult a separate bibliography. and to give them a layout where images are close to the relevant content, not constrained by page layouts. And of course, we want to take advantage of the opportunities that web pages offer for hyperlinking, dynamic expansion of abbreviations, use of pop-ups, and so on. So our problem is how to go from this to this. Well, the answer is to use an interoperable intermediate format, marked up to characterize the text's contents and to enable relationships between different parts of the text and other data sources. We decided to use the Text Encoding Initiative, or TEI, framework for XML because it's long established, stable, well documented, and very, very rich. This lets us meet our editorial principles, as I've just explained, to provide a rich practical experience for our readers, whilst also staying as close to the original texts and layouts as possible. We will correct obvious typos, but retain the original texts, but we also have the ability to add a curatorial update as a separate block of text, and because we're presenting images online, we need to read clear rights, and this means that we'll need to update the credit lines and move them from the back matter into the individual captions. Clearly, doing all this wasn't going to be simple, and we decided to start with a pilot project. The aim was to set up a production pipeline that starts with desktop publishing files and ends up with catalog HTML and images being served to our website via our middleware, and to work out how long it would take to process the 700 plus existing entries along the way. The pilot project ran from October 2019 to March 2021, and it involved a range of people from digitization houses, picture researchers and proofreads, through web developers and UX designers, and including Jeremy, who was developing the XSL templates needed for the project. We chose 5 paintings from amongst our list of 100 highlights, and these covered catalogues published between 1998 and 2018. Now, one point I'd like to emphasize is that for various reasons, ours is a really low-tech solution to the problem of generating HTML catalog text. Other online catalog publication pipelines exist, but they rely upon implementing a quite complicated technology stack before being able to generate the files. After the initial file conversion to XML, which was outsourced, we simply used 2 free tools: an XML-enabled text editor to mark up the text, and a free XSLT processor. Use of a spreadsheet paid for or free to ease the generation of command line transform commands is entirely optional. We found it helped. And these on their own are enough to generate web-ready HTML files. We only use complex software when it comes to publishing our web pages. Our SIM middleware for integrating the catalog pages with our other collection data, and our web CMS Umbraco. Now, I should add that for production, we are using the fully featured Oxygen XML editor. An academic license is pretty cheap, and it has various functions that make day-to-day work a lot easier, but it's absolutely not necessary for the pipeline we've set up. Now, this is the workflow that evolved. It starts with conversion of the text to XML and some basic normalizations. If a text has been OCR'd, it's proofread. There are a series of iterative steps applying automated and manual markup, which are centered around structuring, correcting variable markup in the originated files, and adding the identifiers and references needed to make the web pages work, as well as marking up content, glossaries, abbreviations, and converting formatting tags so that they identify the particular kind of content being highlighted. Now, we had hoped to extract data into a central database file, which could be used to repopulate entries from a central standardized source. That's the block highlighted in yellow on the slide, but time and money ran out. Once the markup is completed, we generate trial HTML pages, and the whole thing is proofread to make sure nothing's been garbled and everything is where it should be. Any changes required are made to the markup, and to the XSL templates if the style sheets have failed to take some new peculiarity of the text into account. Then the XML and accompanying images are ingested into the SIM, converted to HTML, and delivered to Umbraco, which publishes them to the website. Now I'm going to hand over to Jeremy, who developed the XSL templates that make it all work, to talk a little about that.
Hi. So overall, the objectives of the XSL transformations were to produce XML representing semi-structured text that's fit for reorganization and reuse, to establish internal references and the basis for references to and from external resources as well, which will be completed using the middleware that Rupert will return to later on. And so the concrete outputs would entail rich TEI XML files and one HTML file for each painting and artist, and the same for EPUBs. So going to click forward, yeah. So Rupert's already touched on the staged approach to processing, which includes 6 XSLT-driven stages, plus a 7th that we recently added for born digital catalogues, a kind of pre-processing stage. The stages were necessary because certain automated steps couldn't proceed without manual interventions, whether that's in the form of proofreading or manual markup tasks like adding key structure and IDs, or inserting tags for references and abbreviations into the text. Incidentally, there were also style sheets that were run to inform these manual tasks by checking for elements that lacked attributes and so on. Anyway, it's also helpful to break down lots of transformations into sequential steps, because when you try to make too many interdependent operations happen within a single style sheet, it can get extremely complex. And breaking things up also lets us check on the outputs of each process, not to mention aiding debugging. Most importantly, though, it simplifies things when one step depends on the completion of another. So, for instance, in stage 6, that includes separate style sheets for each attribute of type and N and XML ID, and each of these then builds on the output of the previous one. And then also in stage 6, another style sheet merges in an XML file with corrected file names. Then in stage 8, another series of transforms use all of these newly added attributes to start to build links between references and their targets, and to expand abbreviations, so one thing follows from another. Then the final stage is transformation into HTML, of course, and this should be mistake-free, having gone through all the previous stages, which means that it can be published onto the web without any further human intervention. I'd never worked on an XSLT challenge as large as this. I'd done some TEI before, but this was at another level. And a couple of the challenges were particularly noteworthy. So virtual documents, well, although I said it was better to break down interdependent operations into a series of style sheets, this wasn't so feasible when it came to generating the final output of HTML or EPUB. The HTML document that we generate represents a core of data from the painting or the artist's entry, together with a whole collection of other elements that are assembled from elsewhere in the catalogue, sometimes by recursion. A templating language, meanwhile, works best when it's applied to a set of elements of a more known form, and you can't really create a part of the output and then later on in the process go in and fill in some of the gaps. So we decided to do a lot of the selection logic first to generate a sort of virtual XML document in memory as an XSL variable, which would then contain only the elements that will be needed in the final output. So here's a simplified view of a catalogue from which we want to generate the HTML for painting 2. A template called compile entry frag picks out that entry, painting 2, along with information about the artist that it's attributed to, and any appendices that the entry refers to, along with the standard front matter and list of exhibitions, the whole list of exhibitions. And this results in a virtual XML, in a virtual document held in an XSL variable, and that is then passed into a cascade of templates to generate the HTML. It seems to work pretty well, but debugging is complicated. The other kind of recurring theme was recursion. XSLT isn't really all that well adapted to recursion, depending on the context, which is trivial in many programming contexts. So in the virtual document I just talked about, that isn't actually complete. It only contains the content that's in predictable places. But the HTML for each painting entry also needs a bibliography and a list of exhibitions and abbreviations and a list of glossary terms as well. So these lists will contain items that could be outside the entry, and they might be referred to either directly from that entry or else by other things that the entry refers to, and they themselves can refer to other items and so on. So these referenced items are not so simple to grab. And instead, the virtual document just provides a starting point for a recursive process of compiling IDs for the referenced items. So here, the chain of inference looks like this. Collate ref IDs is a template that looks at all the references in the virtual document we just made and passes them to recurse ref IDs. This then looks at the whole document, the whole catalogue, for all of the things that were referenced, and it checks if they themselves refer to anything. And if they do, it follows these, recursing around to do this again and again up to 5 times. Then it passes the result back to collate ref IDs, and the result is another variable that holds a list of all of the IDs for those referenced items that refer to the compiled entry, and wherever it doesn't, regardless of where they are in the original document. And then they can be sorted and deduplicated and then used as the basis for making the HTML lists. So that's a little bit about how we went from very raw XML to refined TEI and HTML output ready for publication. Now come back to Rupert to explain how this pipeline is integrated into the production process.
Thanks, Jeremy. Well, we're increasingly using middleware to aggregate collections-related data from multiple sources and present it via a single endpoint. We used the SIM, and so we commissioned its suppliers, Knowledge Integration, to configure it so that it would do the following. It first takes the finished XML file, any accompanying image files, and Jeremy's XML to HTML XSL template. It uses these to generate the HTML files, transforming any internal hyperlinks to links to other files or other entities within the SIM. It adds them to the SIM's file store along with copies of the accompanying image files and the source files. If necessary, it creates a primary record for the individual catalog entry and links it to the SIM records for the relevant publication and painting. It creates a version sub-record for the particular version of the entry that's being extracted. It assigns a persistent identifier, a PID, to the newly generated HTML file. It also ensures that one additional PID for the current version of an entry is attached to the latest HTML file. Now, this is important because as an academic resource, researchers will need to be able to cite a particular version of any given entry. And as we've seen with locks for curatorial updates and so on, these will change and will be updated. It's one of the virtues of digital publication. And the process then writes a copy of the relevant files representing this version to the SIM's backup vault, which allow us to reconstitute it in the event of total system failure. The SIM is then queried by Umbraco and the relevant files and metadata are retrieved and cached in Umbraco for delivery to the gallery's website. So, over the course of the pilot project, we spent about 51 days on text markup, including the use of automated tagging using Jeremy's style sheets wherever possible. The 5 entries that we worked on totaled 115,000 words. That's the length of a reasonable novel. So it equates to marking up about 2,250 words in a day. This means that marking up all our painting series catalogues would take 2,016 working days at a slightly revised estimated rate of 2,650 words per day. But then over that entire collection, we are talking about something like 5.3 million words. It's clearly not trivial, but it is doable. And at just over 9 years, it compares quite favorably with the 24 years that would have been required to put those 12 catalogues through the press according to our usual production schedules. But the initial pilot project has also helped us to identify what we need to do to publish catalogue entries digitally before they go to print. If we do this, it would mean that we could release single entries or small groups quite quickly without having to assemble a huge print volume of 60 or 70 entries before publication, which makes writing catalogue entries a much more attractive proposition, and it lets us incorporate their creation into other projects such as exhibitions. So we're piloting a revised pipeline for born digital catalogues with entries for our 10 paintings by Raphael. Now, these were originally going to be published in time for our delayed quincentenary Raphael exhibition. He died in 1520, but the show actually opened on the 9th of April this year. But really quite significant delays to the writing, plus an unexpectedly time-consuming sim upgrade, mean that our aim is now to get at least one entry online before the exhibition closes on the 31st of July. As part of this, we've reviewed our pipeline and XSL templates so that we can pass entries through the markup pipeline one at a time rather than work on a whole catalogue at once. We are also refining the versioning in the sim so that unchanged entries aren't reversioned when a catalogue file is parsed for newly completed entries. We're also adding richer version information and pre-formatted citations for the entry into our XSL template so that those can be delivered through to the website itself. Now, the gallery is also planning a major program of projects in time for its bicentenary year, which runs from May 2024 to May 2025. Some of these fall under the umbrella of our Digital Dossiers program, which aims to start making everything we know about our paintings available in one place. As part of this, we will use our cataloging pipeline to digitize 200 entries in time for the bicentenary. The bulk of these will come from the painting series of catalogues, which means that we will digitize about 20% of it. We'll also use this opportunity to make some further refinements to the pipeline, notably creating a database file of cited elements, bibliographic references, exhibitions, etc., that are formatted consistently and that can be reused across multiple existing and new catalogues. We'll also improve the SIM's handling of the HTML files so that it removes links to as yet unpublished entities. And later, we'll add the ability to include links to external identities based upon automated tagging. This tagging will be carried out during a collaborative doctoral project that we've set up with the GATE team at the University of Sheffield. The research project is called Natural Language Processing for Art Historical Information Extraction. An initial stage will investigate the creation of a highly tuned pipeline for named entity recognition and entity linking for art historical texts. And it will go on to use the catalogue text as one source from which to automatically extract meaningful data from provenances, technical descriptions, etc. And we're still taking applications for that studentship via findaphd.com if you're interested. We also hope to extend our Raphael pilot into a major ongoing program of digital-first cataloging. To conclude briefly then, I hope that we've shown you how, in transposing our print-first cataloging culture into a digital-first one, we have established a symbiotic relationship between the National Gallery's traditional way of publishing catalogues and digital technology. I should just say that the online catalogues are not yet at that URL. There are some old handmade HTML ones that it's best to draw a discrete veil over. But we should have things up there within the next couple of months, so do please keep watching that space. And thank you for your attention.
So thank you very much, Rupert and Jeremy. It was an exciting presentation. Do we now have any questions from the audience, maybe? Then just wave me and I will bring the mic. Or not yet, everybody is already browsing this web page you shared.
Well, don't do it just yet. As I say, they're not up at the moment, but they will be soon.
Mm-hmm. How soon? Can you tell?
Well, we really hope that we'll have the 5 pilot ones and at least one of the Raphaels up by the end of July, when the Raphael exhibition closes. That's our current deadline.
Mm-hmm. Great. Anyways, I think we should keep an eye on your doings and those projects, future projects you mentioned. They also sound really interesting. So if you don't have any questions now, then thank you again.